SBO is the best.
Boom, let's lock in. So movement analysis is where we're going to look at levers, mechanical advantage, and we're going to finish off with planes and axes. So by the end of this video, you'll be able to know the three classes of levers and apply them in sport. So the first, second, and third class. Know the definition of a mechanical advantage and apply that to the levers. Know the three planes of movement and the three axes of movement, and also apply them in sport. So let's get straight to it. Levers are fascinating because they make you think, how is it that small muscles in the body can move a big body part really fast? Like, how is it that your calf muscle, a tiny muscle at the back of your leg, can have your whole body standing up on your tiptoes? And that's what we're going to explore in this video. So a lever, basic definition, is just a rigid bar that pivots around a point to create a movement, and it's made up of three parts: the fulcrum, the effort, and the load or resistance. The fulcrum is this triangle here, that's the pivot. The load is this box, which is obviously acting downwards in this, so that's the load. It's gonna say L here. This is the load, also acting downwards here. It's gonna say L. This is also the load acting downwards here, and the effort right here, we're going to label it with an E. So fulcrum is the pivot point, which is usually the joint. Effort is the force applied, usually by the muscle contracting, and the load or resistance is what you're moving. So whether you're moving a body part or you're moving an external weight. So the first class lever always has the fulcrum in the middle and then the effort and load on either side. So I could have easily just have swapped these and have the load here and the effort on the right here. It doesn't matter. The second class lever has the load in the middle and the effort and the fulcrum on either side. And lastly, the third class lever has the effort in the middle and the load and fulcrum on either side. These are classic examples of each lever class. So the first class lever classic example is at the neck, heading a football or any ball. Second class lever at the ankle, standing up on your tiptoes. Third class lever at the elbow, doing a bicep curl. So let's look at these examples. So boom, at the neck here, got a little guy right here. Let's just draw a football right here because we're heading a football. For example, draw a football right there. We're heading a football, right? So let's say this is our lever, this is our rigid bar right here, and the fulcrum is obviously the neck joints there in the middle. The load is coming from the football. The football is applying a load onto this lever, so we can represent that as the load here. That's the load, fulcrum, and the effort is coming from our neck muscle. So we're heading this football in front. Our effort is coming from the neck muscles behind here. So our effort will be here. Okay, on to the next example. We have second class lever. This is a tiptoe or any exercise that involves you getting into this position, so getting ready to jump or doing calf raises or anything of that sort. So again, we're going to draw a calf muscle here because that's going to be our effort. Our calf muscle at the back of the leg right there. And then let's just say this is our bar somewhere here. So the pivot is actually where the toes meet the ground, so that area there is our pivot. And then the effort is coming from the calf muscle, so we can draw our effort right here. E for effort, F for the fulcrum, that's the pivot. And then the load is coming from your actual body weight. So if you think about it, this leg goes up and it makes up your body, and your body has weight which acts down, and that load is here in the middle of our second class lever. So L for load. And lastly, third class lever example, our classic bicep curl. Okay, so this is a weight that you're lifting. We're gonna automatically label this as the load because that's the weight that you're lifting. Let's just draw our lever somewhere here like this. Okay, so we can automatically see that the elbow joint will be our fulcrum during this bicep curl. That is the joint, that is the pivot. So we're gonna draw that as our fulcrum. Now the effort actually doesn't come from the elbow because the bicep actually attaches to the forearm. If you can see, it attaches just in front of the elbow. So the effort actually is just in front of the fulcrum. So we can draw the efforts here. E for effort. And then we have that load there, which is on the other end of our lever, and we can just draw that there as L. So that is a third class lever, and a very, very good trick. This trick never ever fails me to remember exactly how each lever looks like. Is always remember 1, 2, 3, F, L, E. This means that for the first class lever, the fulcrum is in the middle. Second class lever, the load is in the middle. Third class lever, the effort is in the middle. So 1, 2, 3 FLE. FLE tells you which component of the lever is actually in the middle. So remember that. Okay, now what do we mean by mechanical advantage? Mechanical advantage is a concept that tells you about whether a lever system is better for producing force or it's better for producing speed and range of movement. So to be able to understand whether a lever gives a mechanical advantage or not, you need to understand what the effort arm and the resistance arm is, or the load arm. Sometimes it's called a load arm. So this is let's just use a first class lever as an example. So this is a first class lever. We have our fulcrum right there. We have our load. And then we have, oh, that's a bad arrow. We have our load. And then we have our effort. So we have the effort arm and the load or resistance arm. Like I mentioned, the effort arm is the distance between the fulcrum and the effort. So that's the effort arm. And then the load or resistance arm is the distance between the fulcrum and the load. So that's the load arm. That's the load arm or resistance arm. And basically, if the effort arm is longer than the load arm, then that lever has a mechanical advantage. But if the load arm is greater than the effort arm, then it has a lower mechanical advantage. So we see that in this first class lever, none of them are bigger than the other. They are each the same size. That means this doesn't really have a big mechanical advantage or doesn't really have a small mechanical advantage. It's more neutral and it varies depending on the joint and depending on the movement. But what you will need to analyze is that second class levers, if we draw one right here, remember FLE 1, 2, 3 to remember which component goes where. Second class lever load goes in the middle, and then the other components go on either side. So I'm gonna put our effort here. Second class lever, we can clearly see that the effort arm is longer than the load arm. And what does this mean? This means it has a big mechanical advantage. And having a higher mechanical advantage means you basically need less effort to move a greater load. Meanwhile, third class lever, if we draw that out, remembering FLE 1, 2, 3, So I know that my effort will be in the middle, and then the others will go on either side. So our fulcrum here, the load there, we can clearly see that in the third class lever, the load arm is greater than the effort arm. That means mechanical advantage is smaller. And this essentially means you need more effort to move a certain load, but you can move with more speed and greater range of motion. Alright, let's finish off with planes and axes. So, a plane is just an imaginary flat surface that movement occurs along, and an axis is an imaginary flat line that the body rotates around. So think of planes like slices, and an axis are like kebab skewers that go through the body. And we have 3 sets of planes and axes you need to know, and also know the type of movements that occur in those planes and axes. We have the frontal plane and sagittal axis. So movements that occur in the frontal plane and the sagittal axis are usually adduction and abduction type of movements. So things like cartwheels and star jumps. Next, we have the transverse plane, and it doesn't say the axis name here, but the axis is the longitudinal axis. So longitudinal axis, that long axis that goes from the head all the way down to the toes, and the type of movement that occurs at the transverse plane around the longitudinal axis are rotation movements. So like a 360 spin in a dance move or by a ballet dancer, discus turn or ice skating spin, and things like that. Lastly, we have the sagittal plane and the transverse axis, the type of movements that occur at the sagittal plane and about the transverse axis. Transverse isn't spelled right, there's one extra S, ignore that. Type of movements that occur are flexion and extension movements, so like running, forward rolls, front flip, back flips, squats, and movements of that sort, bicep curls and things like that. Okay, that is it for this video. If you want to practice what you've learned in this video, I highly encourage you to check out our website Super PE Online for tons of revision resources which will help you ace your exams. All right, see you in the next video.